So today we will be seeing the various cores of AWS, which is Amazon Web Services, where we will be delving into the depths of each and individual AWS infrastructures, predominantly the widely used services. Up next, we will be seeing the must monitor metrics in your Oracle Cloud infrastructure and Google Cloud Platform, and also Oracle Autonomous Database environments. The third topic for today is monitoring your hyperconverged infrastructure. There are specific monitor types in Applications Manager that helps you monitor your hyperconverged infrastructure, which we will be seeing over the course of this webinar. And lastly, we will be seeing trend analysis and resource planning, which will help the IT admins optimize their compute resources. Now, the big question is why companies are migrating to cloud computing. Now, the fact that to host a website, it is essential to buy a stack of servers, and the most important thing to keep in mind is the traffic and also the necessity to add more servers, maintaining these servers and monitoring them regularly. So these are one of the most common factors for an on-prem monitoring. Now, the problems with an on-prem monitoring is it is expensive because more number of servers, more number of bandwidth, and larger amount of traffic needs to be provided. And at the same time, should there be any issue, troubleshooting them could also be a little time-bearing. Now, these are some of the factors why many companies have decided to migrate from on-prem to cloud computing. Now, how do we monitor cloud applications in APM, which is Applications Manager? Now, usually system admin handles many end users who uses multiple cloud applications like Amazon Web Services, Oracle Cloud, or Google Cloud Platform. So there are constant doubts on how to track the performance of all the cloud applications. What if something goes wrong? How can the system admin know? And how can the root cause analysis of a specific issue is done? Now, this is where Applications Manager comes handy. So what Applications Manager does in terms of monitoring cloud applications? It tracks the number of services that are hosted on your cloud applications, identifies the root cause, which has been or which was determining the performance issues. It creates an alerts based on the threshold profiles that are set to a specific set of services or cores. And notifications is something where a user gets alerted via an email or through an SMS to a mobile device. Now, once all these things have been effectively identified, the end user takes corrective actions to ensure that their cloud services or cloud cores are functioning fine without any issues. Now, the first topic for today is delving into the depths of your AWS infrastructure. Now, Amazon Web Services has various options for monitoring in Applications Manager. Some of the available services as of now would be the Elastic Compute Cloud, the Load Balancer, Relational Database, which supports monitoring of various databases like MySQL, Postgres, and Aurora database as well. We also have the Simple Storage Service, Notification Service, Dynamo Database, and AWS Billing. Now, let us go into the UI to see So a user requires to log in, and he or she would be able to log into the UI. And the first thing that is required to be done is to ensure that the credentials are given in the first place. And then the user would be logged in. Now, there are various monitoring options here in Applications Manager, as the monitor page suggests. So the cloud applications is something that we are discussing in today's series. Now, first up, let us go ahead and see how a user can add an Amazon Web Services monitor, for which the user has to click on Add New Monitor and pick the monitor type under Cloud Applications, which is available down at the bottom, and choose Amazon. Now, since AWS has various services listed for monitoring, a user has to ensure that the prerequisites are completed in the first place. The reason being, Applications Manager is an agentless monitoring tool, and the required prerequisites have been given here right on the help card. Now, once the prerequisites are completed, we are required to choose the services from the various options that Application Manager offers by clicking on this particular drop-down, which will help a user to identify or pick various services like what we have over here right now. Now, the basic information that needs to be provided is the access key ID and the secret access key. Now, there are two account types. One is AWS Global and AWS China. So once all these details have been provided, we will have the monitor added, and let us go ahead and see how the AWS monitor looks like. So this is the Amazon monitor which we are looking right now. So let us have a quick look at some of the widely used services. So to begin with, it is the Elastic Compute Cloud. Now what we see here is the number of EC2 instances that has been discovered, and it has various information that requires constant monitoring. Now let me choose one of the instances, which gives us a wider perspective into what the EC2 instance has in offer. Now every time an instance is hosted on the cloud, there are various metrics for monitoring. Now what we have over here is the CPU utilization of this particular instance, followed by the network traffic, which will help a system admin understand the total amount of traffic that has been sent in or sent out. And we also monitor the disk input output operations, which is the read write operations, letting a user know the total amount of operations that is being performed on the disk at any given point of time. Now, yet another important metric when it comes to identifying on an EC2 instance is the configuration. So ideally, any EC2 instance would have a specific storage allocated. So what we have here is a volume that has 8 GB of allocated size, and every time a volume has been dedicated in the EC2 instance, a snapshot has been created with a unique ID for that particular volume. And it also gives the user the information for as to when exactly this was created and when exactly this was attached, so that it comes into function. Now down below, we have other metrics for monitoring, like the total volume versus the idle time, which means the total time taken for the utilization of this particular volume or this particular disk. So further down below, we have other attributes like the volume, read, and the write latency. So this gives a user an option where they can set a threshold to identify or to determine the read-write latencies, which will help the end users who use the compute instances without any hazards. And further down below, we have the network traffic, which is the volume traffic for this EC2 instance, where the read bandwidth and the write bandwidth has been determined along with the throughput. So these are some of the key metrics which will help the system admin identify what amount of information needs to be drilled down or needs to be dedicated to a particular EC2 instance, such that when an end user uses it, they will not encounter any performance hazards. Now, these are some of the widely used important metrics on an EC2 instance. Now, let us go back to the Amazon monitor, the web services, where we will be seeing other metrics. So to begin with, we have the load balancers. So the load balancer in AWS has been divided into two sectors. One is the application load balancer as well as the network load balancer. So let us have an insight into how the network load balancer works. So this usually helps the system admins determine the amount of connections or the amount of people that are using this particular load balancer or particular instance, with the amount of traffic that has been dedicated to this particular compute instance or a specific AWS service. Now, as we see here, we monitor the TCP connections. So as we can see, there are 4 active connections and 6 new connections. And similar to that, we also monitor the TLS connections, the total number of data processed to the TCP as well as the TLS, and the total consumed load balancer capacity units. Now, each load balancer, a network load balancer in this case, might have a dedicated amount of network bandwidth. Now, what if this particular load balancer has crossed beyond the set limit? This will have an impact on the total bandwidth which has been allocated to the web services. Now, in order to avoid such discrepancies, we have the option to monitor the capacity units on a specific load balancer, where a user can configure alarms by setting a specific, a user customized threshold, which will alert the user whenever there is a threshold that has been violated. Now, a particular load balancer, a network load balancer, might have various amount of errors, which may be a client TLS negotiation error or maybe the target negotiation error. These errors might not be visible to a naked eye, but on this particular monitoring tool, where we have this particular errors that is determined or identified, it lets the user drill down where exactly the issue is. And also added to that, we monitor the reset package statistics that helps the user identify the total number of target reset packets or the total packets that has been given to a particular load balancer. Up next, we have target groups. Now, whenever the network load balancer has been enacted, so it identifies various objects like a healthy and unhealthy hosts. So each and individual load balancer has various targets, and each target is hosted on a specific port number. It is communicated through a protocol, which is TLS in this case, and the type of target, which is an instance or maybe a database, and what was the timeout to access a particular instance. So had this been the case, what would be the total number of healthy hosts that are available to be accessed within a given point of time or a given interval of time, which is the timeout? So these are some of the aspects which will absolutely help any AWS admin to ensure that the EC2 instances are well optimized with the help of the various resources which are available. And that can also be drilled down with the use of the load balancer. Now let us have a look at the relational database services. Now, AWS has offered monitoring of relational databases where they have enhanced their existing databases like Postgres or MySQL. And added to that, we also monitor the Aurora MySQL, which is with more enhancements, where we can see the overview, that is the database hosted on a particular server or a particular instance, will help us identify the CPU utilization or the available storage for this particular instance. Further down below, we also monitor the memory utilization, which is also another essential aspect. And the important factor when it comes to monitoring any database is the number of connections or the number of sessions that is available every time a connection is being made. So these are some of the common metrics. Now let us go ahead and have a quick look at the Aurora database. Now, ideally, any database might have various operations running in it. And as we can see, we have the replica lag, the total lag that is available on a specific database, the number of transactions, which is active transactions or block transactions, which means whenever a query is being executed in the background, there might be certain time waiting queries or block queries, and all these queries are what is determined as a transaction, and that is what we discover it and help it identify as database transactions. Now, yet another important factor or important metric when it comes to a database monitoring is the cache hit ratio. So an admin has to constantly monitor the buffer cache hit ratio to ensure that it does not go below 90% of the set threshold, because should there be any decrease in the utilization, it might have an impact on the overall performance. Now, apart from what we have over here, which is the transaction monitoring as well as the buffer hit ratio, we also monitor the number of deadlocks seen in the Aurora database and the total bin logs disk usage. Now with this, let us go ahead and have a look at the other two important factors on AWS. The next important factor is the notification service, which helps the user drill down various factors like the number of messages that has been sent or delivered, or the total number of notifications that has been sent across each and individual region. Now, right at the beginning, we did choose AWS Global. So the moment we chose AWS Global, it picks out various regions that is available. And as we can see, each and individual region has its own amount of messages or notifications that are delivered or published, or the number of topics that are available. So this way, an admin can easily determine what is the total amount of charge that has been made for each and individual message or a notification that has been delivered or that has been failed. So there are various factors for which thresholds can be configured, and these include topic count, the messages published, notifications, those that are delivered or failed, and the SMS charges. With this, let us move ahead and see how billing helps any AWS admin. Now, cost cutting is one of the essential factors when it comes to managing various resources. Now, it would be a tedious task in order to identify or monitor various metrics with the help of the available resources. As far as AWS is concerned, we have quite a few metrics to be monitored, like the notification service, the databases, the cloud instances, or load balances. Now, all these instances or all these services are paid on a monthly basis. Now, what we determine under billing is we identify the total expenditure and also help a forecast to let the users know what would be the amount of money that is being used on these services. Now, added to that, we also identify the month-to-date services spent across various cores or AWS services, like what we have over here. The cloud compute is consuming more amount of finance rather than an Amazon Dynamo database or a notification service or a load balancer. So with these options, a user can identify what is essential and what is not essential, and this billing will help the users avoid over expenditure on their AWS services. Now with this, let us move ahead to our next topic, which would be must monitor metrics in your Oracle Cloud Infrastructure, Oracle Autonomous Database, and Google Cloud Platforms. Now, what is an Oracle Cloud Infrastructure? The OCI, as it is commonly called, has various options like data as a service, platform as a service, software as a service, which are some of the options available for monitoring, along with infrastructure as a service. Now, Applications Manager OCI Monitor helps a user monitor the infrastructure as a service. So up next, we have a slide which helps the user identify how the infrastructure as a service looks like. So in Applications Manager, we monitor the compute, the storage, network services, and various other objects which we will see on the UI in a while. So let us also have a quick glimpse as to what Oracle Cloud Infrastructure in Application Manager offers in depth. So the capabilities allow you to effortlessly monitor the compute elements of your OCI, monitor key metrics like the CPU usage, the disk IO stats, memory utilization. And also it helps the admins keep tabs on critical parameters like boot volume, block volume, view network stats, and understand performance trends. All this is done on Oracle Cloud Infrastructure, which is infrastructure as a service. Now we also monitor the Oracle Autonomous Database under the cloud infrastructure, where we manage the user's pre-configured cloud database environment that uses machine learning and Internet of Things to perform tasks without any human intervention. This autonomous database automates patching, upgrades, and tuning without a manual touch or any required downtime. Users can instantly create new databases and easily convert existing databases, dramatically reducing huge costs. On the whole, Oracle Autonomous Databases are self-driving, self-repairing, and self-securing. Now, before we have a quick look at the Oracle cloud infrastructure, let us also have a quick insight into what Application Manager offers in terms of monitoring a Google Cloud platform. Now, Google Cloud is Google's inbuilt cloud platform that provides a series of cloud services, including computing, data storage, data analytics, and machine learning. Applications Manager GCP monitoring will give you complete visibility into every component of your Google Cloud environment, thereby allowing you to optimize the performance of business-critical Google Cloud services. Now let us go to the UI to see how we can add Oracle Cloud Infrastructure in the first place. To begin with, we go to the New Monitor page and scroll down to the Cloud Apps, where we have options for Oracle Cloud. Now, to add the Oracle Cloud Monitor, it is essential for the user to deploy the OCI.pem key, which is the PEM file path, wherever that particular key is available. Had this been on your C drive, the complete path along with the file name is provided, followed by the other important metrics, which is the tenancy OCID, the user OCID, the fingerprint, which is essentially the password. Now, like we have on the OCI, these are the three different services available for monitoring, like compute, storage, or the autonomous database. Now, once we have everything in place, we will have the monitor added, and let us go ahead and see how Oracle Cloud Infrastructure helps you monitor various options. So this is the Oracle Cloud Monitoring page, where we have the overview that helps us identify the number of compartments enabled in a particular tenancy, the number of storage, which is the number of buckets, the total number of databases available, the compute cloud instances. So let us go ahead and see the compute instance, where we have various instances running on various compartments. Let me choose one of these instances to see the various metrics. Now, this being a common compute instance, it is quintessential to monitor the CPU utilization as well as the memory utilization, which are a common metrics across any cloud compute instance. And further down, we have the disk read-write operations. Whenever any operation is being performed on a disk, like a copy or any new file is being inserted into the disk or installed, all such operations is identified under read-write. And we also monitor the network packet stats or the network stats, which includes the total number of receptions or the transmissions in terms of the network bandwidth. So this is the overview. So we have other options, which is the boot volume. So every time this particular cloud compute instance or the Oracle instance is being booted, there are various metrics which are available for monitoring, like the read throughput as well as the write throughput, or the number of operations which is being performed right at its startup. Up next, we have the network configuration. Like any physical server, this particular cloud instance has a virtual network interface card, where we identify the NIC's name, its private IP address, the MAC address, and identify the number of packets that has been dropped or the number of packets that has been sent to the traffic, where we also monitor the inbound and the outbound traffic, which are the essential factors in terms of monitoring an Oracle Cloud instance. Now let us go ahead and see the Oracle storage. So as we can see, there are quite a few buckets available under Oracle storage and various file systems as well, which are deployed across various locations. Like what we have over here is Frankfurt, Ashburn, and we also have Toronto too. Now let me go ahead and pick one of these buckets so that we can see what amount of metrics this storage monitoring offers you. The cloud storage helps you identify the number of buckets, number of objects deployed well within a bucket. And each time a specific bucket or a specific object has been accessed, there are various requests, which is like the number of users that is trying to get hold of a particular request. That is what is identified as a read request, where we get to see the total get object request count, head object request count, or list out all the available objects in a specific bucket. Now, if in case any operation is being made, that is being identified under the write request, where we can see the delete object, put object, rename, or post object. So these are some of the commonly used read-write operations, and followed by the throughput. So here we identify the number of get requests or put requests, which is identified per minute. That helps a user or a system admin who hosts the Oracle Cloud understand the total throughput or the total performance of this particular storage. Now let us also go back and see the Oracle Cloud Storage, which is the file system over here under the storage. So there might be various files which have been identified or put together in a particular Oracle Cloud storage. So we identify all this storage and we let a user understand the total utilization that has been allocated to a particular storage device, and also help them identify when exactly this file was put into action, what is its last known availability status, and for how long has this been active. Last but not the least, on the storage, we have the mount targets. So every time a storage has been available, there are specific amount of mount targets assigned, where we can identify as to which one of these target is easily accessible and what is its compartment name, and can this be used in order to ensure that the available objects or targets are deployed in these particular mounts. So with this, let us go ahead and see what Oracle Autonomous Database offers. Now, as we have seen just a while ago, what the Autonomous Database does, which does not require any manual intervention. Now, once the database is added for monitoring, a standard Oracle database will have various connection related stats, normal server related metrics like the CPU utilization or the storage utilization. Every time a query is being executed, it identifies the total number of session details and the number of login connections, which is being failed login or failed connections. The statements, which is the Oracle statements which are being running in the background, the total number of Oracle transactions that are being performed. So these are some of the key factors available for monitoring. And added to that, any Oracle DBA would be pretty much interested in monitoring the table spaces, which would essentially help the users, help the DBA identify the performance of an Oracle database. Now, what we have over here is the various table spaces and the total space allocated to an individual table space, the amount of usage that is seen across each and individual table space. Now, further down below, we have the table space status as well as the performance of data files. Now, each table space might have its own status, be it online, offline, read-only, and some of the statuses which would be available provided they are active on the database. Now, this particular table space might have various data files. Now, these data files might have its own operation, which is a read operation or write operation. And as we can see, a specific data file has been identified from a particular table space over here, as we see sysops, and its status is determined as online. Had this been offline, it would have shown the health as red in color, which means that there is a discrepancy in one of the existing table spaces. Now further ahead, we have the number of Oracle sessions. So every time a user logs into a database and performs certain operations like executing a select query or putting an insert query, every single action counts as a specific session by that particular user. Now, what we identify over here is the session ID for that particular user and the username where the number of logical reads or physical reads are identified along with the buffer cache hit ratio. Further down below, we have the session summary, which is whenever the user logs in, from which machine has this user logged in and what program was being accessed, and the number of users that are actively available at any given point of time. Now, the Oracle database will have various processes running, and we identify these processes as max PGA. So as we can see here, the PGA has a unique process ID where we identify key performance metrics like the total space that has been used, the total space that is available, and the total allocated space, and what is the name of a particular program, which is the PGA. And lastly, we have the scheduled jobs. So any database, irrespective of on-prem or being on cloud, the Oracle database that is hosted on the cloud instance has some scheduled jobs for monitoring. And what we have is the scheduled jobs that lets the user identify the total number of active jobs or inactive jobs and what is the last known status of a particular job when it is available to perform its operation. And was that operation successful? If yes, the monitor is functioning well. If no, the status would be false or the last known status would be failure. So these are some of the key factors or some of the methods by which the end user or the Oracle DBA can make use of monitoring the Oracle database monitors. With this, let us go ahead and have a quick look at what the Google Cloud offers. So like any other monitor, we have to navigate to the bottom to ensure that we pick the Google Cloud Platform under Add New Monitor. And to add this particular Google Cloud, a user has to ensure that the OAuth is created and the OAuth provider has been assigned. And once these details are provided, the various performance metrics or various services like compute engine, cloud storage, or the file storage is enabled for monitoring. Now let us go ahead and see what are the various performance metrics available under the Google Cloud Platform. So this is the overview, which lets the user identify the number of quotas, which is the number of network related stats or network information, which is what we have here: networks, routers, firewalls, the target pools, the HTTP or the port related stats. All these performance metrics are available under the Google Cloud. Now, this particular cloud, offered by Google, has been divided into two, which is compute and storage. Under compute, we monitor the performance metrics like the CPU utilization, the memory utilization, and we have the network related stats, which is the inbound, outbound traffic, the total amount of packets that has been sent, any firewall discrepancy like the drop bytes or the drop packets across a particular firewall on the Google Cloud. Also, we have the disk monitoring on this particular Google Cloud instance, which is the individual drives. Like a normal server monitoring, we have over here C as well as D drive and the total space that has been allocated to a particular disk, and the disk read-write operations, its latency, the input-output operations, and all these metrics are available for monitoring on the Google Cloud Compute instance. Now the Google Cloud has the storage, which is classified into cloud storage as well as cloud file storage. Now let us see what the cloud storage helps a user monitor. And every time a user drops a particular file, like a Google Cloud Storage or a Google Cloud Drive, there are various objects inserted into a particular Google Drive. And that is what we monitor over here, which is the number of objects, the amount of bucket size, which is the drive size, the number of requests which is being sent, followed by the network traffic. Now over here we have the request, which is the read request or the write request. So let us say a user who accesses a Google Drive or Google Cloud Drive wants to add a file which can be shared with multiple set of people, which accounts for write request. What if the same user tries downloading an already existing file? That is identified under the read request. And objects. So this determines how a specific Google Drive works. So as we can see here, there are various objects which are various files which has been already available. Now a user can make use of this by performing read-write operations, which is sharing the file, adding a new file, or opening a file to be accessed to perform certain set of operations, or download the particular file, which is the various objects available on this particular storage device. Now added to that, the admin can also identify if there are any recent changes made on this particular Google Cloud, which is what we have over here, that helps you identify the recently uploaded objects. And lastly, we have the category-wise details, which helps us easily drill down the type of files that are available, be it .exe files, or be it image files, or be it DLL or jar files. So we can sort by category to ensure or to identify the ease of access to make a specific category that can be easily used on this particular storage device. Now with this, let us further proceed ahead and see what we have under monitoring a hyper-converged infrastructure. So Gartner, which ranks various monitoring tools, predicts that 20% of business critical applications that is deployed on a 3-tier IT infrastructure will make use of the hyperconvergence infrastructure moving ahead. So what is a hyperconvergence infrastructure? It is a complex or a simple utilization of VMs, servers, network related information, and storage devices. Now, Applications Manager has two different types of hyperconvergence infrastructure available for monitoring. So as we can see here, pretty clear, there are certain aspects or certain important factors available for monitoring, like the compute, storage, virtualization. And the benefit of using this is it reduces data complexity and increases the scalability through a single system, which is a common tool set. Now, the two options available in Applications Manager is Nutanix and Cisco UCS. So what Nutanix offers? It is a native developer of a hyperconvergence technology to integrate both the hardware and the software developed together into a software-defined solution. So this also includes monitoring of software like Nutanix Acropolis, the Acropolis Hypervisor, and the Nutanix Prism. We use the REST API method to collect data across all these important metrics and alerts the user whenever there is any specific event identified in the last port. Now, similar to that, we also have the Cisco UCS, which helps you identify the compute, the storage, network, and virtualization. And also, the use of Cisco UCS is that it reduces the total cost of ownership and improves the business agility. Now let us quickly get into the UI to see how these particular monitor types are added. So I am in the new monitor page where I can pick Nutanix, and as we can see here, a user has to simply specify the cluster hostname or the IP address, and further down below, followed by the credentials, there are multiple options, which is a VM discovery. Now, what happens if there are multiple virtual machines which are being added every time? If a user does not want these VMs to be monitored or discovered, or just to know the status, these options helps the admin make use of the monitoring however they want it to be it do not discover, be it discover the metrics but do not monitor them, or discover and monitor the VM metrics. So these are some of the options which will have an impact on the new VMs that are added on the actual Nutanix environment is being added for monitoring as well. Now let us go on to the monitors page to see how a Nutanix monitor works. So over here under Nutanix we have various options, which is the virtual machines available under the cluster and the number of VMs hosted on a particular Nutanix environment. Now as we can see, there are 3 different VMs, and each and individual VM has its own type of host, be it OpenShift, KubeNode, or KubeMaster, which is done through Kubernetes. Now let me open this particular VM, which is hosted on a VM, which is an OpenShift. So as we can see, this particular VM has the monitoring metrics of the CPU utilization, the memory utilization, and the VM details that gives you the number of virtual CPUs or the virtual memory, the virtual state being on or off. And it also monitors the number of storages, which is the number of disks that has been assigned to a particular virtual machine. Now what we have here is an individual disk, or a virtual disk to be precise, where we monitor the total capacity, the free capacity, or the use capacity available for this particular storage. Now, when this particular storage or when this particular VM has been added as a server monitor, we can also monitor the processes running on that particular host. Now, coming back to the Nutanix monitor. So we can monitor the total number of disk details that is assigned to this particular Nutanix environment, not just the VM. So as we can see, there are various containers available down below, and there are certain key metrics, which is the replication, the storage, as well as the path in which a particular disk is available, the type of the disk, be it SSD or be it HDD, and what is its status. Is it normal or is it being overutilized? All these things. Now up next we have alerts as well as events. Now every time a Nutanix environment is being utilized, there are various factors which might affect the performance of this particular environment. So each time an issue has been seen, it triggers an alert or an event which is further available down below. So this will help the user identify what are the various alerts that can be seen, and from where exactly was this particular alert identified, and what is its resolved state. Is it resolved yes or no? When was it resolved? Was it auto resolved? And a user acknowledgement time for a particular alert. Now in the case of an event, there are other metrics which is quite similar to auditing. So as we can see, a specific user has logged in from a particular IP address, and what changes or where exactly did the user log in? What has affected? So these are the kind of things which are notified or logged in the event details, and it helps in ease of monitoring when it comes to the Nutanix environment. Now, similar to the monitoring of the Nutanix hyperconvergence infrastructure, we also have Cisco UCS, where the amount of metrics that needs to be provided is the host name or the IP address of the Cisco UCS device and the credentials. Now, once these informations are given, we have to go ahead and look at the newly added monitor, which is Cisco UCS. Now, what we have over here, The Cisco UCS has various amount of metrics to be available for monitoring, which includes the chassis, the rack mount, the number of processors, the fans, the input-output modules, any faults identified on the server, and the ports on which a specific server is run. Now, the overview has the response time, the various amount of components like the number of chassis servers available, number of rack mount servers, or number of processor units. So these are some of the components which are available on the overview. Let us have a quick look at some of the key metrics available under Cisco UCS. To begin with, chassis. There are various chassis servers available, and each server has its own model, and we identify the power on off state of this particular server, and we can also see the network interface card along with the metrics which will help the system admins or the IT admins identify the top servers by memory consumption. And further down below, the memory and the CPU utilization across each and individual server, and the total number of CPU core count which is available, the space that has been determined. So instead of going to each and individual server individually or manually, once this particular environment has been added in Applications Manager for monitoring, this will make the admin easily monitor all their infrastructure from a single place without the hassles of going to a particular rack or a mount server or identify the chassis, what is its status. And to overcome all these hassles, we also have various metrics like the motherboard details or the top 10 servers by power consumed and the temperature. So it is quite known fact that temperature also has an effect on the power supply, or it might have an impact on the server's performance from being overheated. So it is essential to maintain an optimal temperature for these rack servers or the chassis servers. Now, with these metrics, the chassis environment can be easily monitored. Now, up next, we have the mounts. There might be various rack mount servers, and each server might have its own unique model. And it might once again has its own operations, which is if this particular rack mount is operable or not. So these are some of the metrics available for monitoring, along with the memory consumption across all the servers, and CPU as well as memory utilization, power consumption, and the temperature stats. So across this Cisco UCS environment, it is quite essential to monitor the temperature of the motherboard, the memory consumption or the utilization of the disk, or the CPU utilization. These are some of the common factors or very important factors when it comes to monitoring the objects available on the Cisco UCS environment. Now, yet another important factor is the processor. Now, each and individual environment or a chassis or a rack mount might have its own amount of processor running, be it Intel or be it AMD. So whatever the option or whatever the metrics available on this particular environment, we identify that and drill down these options as the temperature and the input current provided to a specific server, be it a chassis or be it a rack mount or be it a fabric server. Now, further down below, we monitor the individual processor, where we identify the CPU temperature, the input current, the equipment, what sort of server it is, and the type of the processor that is available, the speed that is enabled on a particular processor. So further we drill down, the more amount of information we have across each and individual CPU that is hosted across each and individual objects across this particular Cisco UCS environment. Now with this, let us move ahead to the last topic of the day, which is trend analysis and resource planning. Now, over the course of this webinar, we have seen monitoring of cloud instances, which are the compute instances, the storage devices, and various metrics across different cloud options. Now, with all these factors available, the important thing for a system admin would be identifying performance bottlenecks across a period of time, identifying the utilization of a specific instance across a different time interval. How can these resources are optimally utilized without overloading on a particular object or checking the performance metrics of a specific disk or a specific drive? Now, how can this be achieved? We have a trend analysis report where there are various report types that helps the utilization of a specific metrics can be segregated in terms of hour of the day report, day of the week report, statistical report, and a heat chart. Now, added to this, we also have a forecast report that predicts the utilization of a particular disk metric across a series of 2 years from now on. So this way, the admins can easily ensure when exactly a particular disk or a particular virtual drive is being at the verge of its utilization, which is at its 100%, or maybe if some of the disks are not being used, what is its utilization across 5 months or 6 months down the lane. So these are some of the metrics which are available in terms of reporting, which we will see on the UI right away. Now, what we have over here is the reports option available, and we have this various reports that is available. So let us begin with trend analysis. Now, a user has to pick one of the options, one of the monitor types from this, and I chose Amazon over here. Now I can go ahead and choose at a glance report, which gives me the options to identify various metrics like the bucket size, the number of objects, or the virtual folders. So these are what we have on this particular trend analysis report. Now there are various metrics, various options, so which can be drilled down to be identified as to what exactly is the uptime or the downtime or the number of objects available over a series of various time intervals. So these are some of the options which is available on the trend analysis report. Now further down below, we have the forecast report. Now these are some of the monitor types for which forecast report can be easily drilled down, and we can easily see how the metrics are at the verge of its utilization. So let me go ahead and see the report, which is a forecast report of the disk utilization of a particular server. Now, as we can see, there are 3 different disks available over here, and we have each and individual disk identified over its various utilization factors. Now, what happens is we can drill down the utilization where we can compare the trend over the last 30 days and identify the trend or identify what is its forecast over a series of 10 months over here. Now, as we can see, there is a granularity in terms of monitoring the individual disks. So what if I pick disk C over here? Now, as we can see, this has been constantly utilizing 50% or so until today. Now, what would be the utilization after 10 months? So as we can see, the utilization has drastically reduced over the next series of months, and at a point of time, the utilization will be 0. Now, this is for a disk that is less utilized. Now, for a disk that is being utilized more, the trend would go up, and it helps a user drill down when exactly the utilization of this particular disk is going to be at its peak, which is 100%. Now, there are various time intervals over here that helps a user predict what is the utilization at various time intervals across various months. So these are the various options in terms of monitoring or identifying the reports, how to optimize them. Now, with the evolution in the cloud monitoring, there are various requests in terms of monitoring various cloud services as well. Now, what we have seen over this webinar is the key performance metrics across key web components on AWS. Now, in our upcoming releases, we have various features under Amazon Web Services like Lambda, Simple Queue Service, Kubernetes Service, and Microsoft Azure, Google Cloud, Kubernetes, and Exchange Server 2019. There are minor enhancements, which is monitoring of the SharePoint 2019 as well. Now, later this year, we will be monitoring the VPC and the VPN on an AWS, the CloudFront, and support for United States government cloud. And added to that, we will also be adding load balancer on Microsoft Azure and add more cloud functions under Google Cloud Platform. So in the Q4, which is the last quarter of this year, we will be seeing support for Alibaba Cloud, which is one of the clouds which has been on constant rise with the evaluation of technology in terms of cloud monitoring. And we will also be adding Beanstalk and Elastic Cache in AWS and monitoring of ExpressRoute and virtual networks on Azure. So over this course of webinar, we have discussed the various options available on Amazon Web Services, which is the notification service, the databases, cloud instances, and the billing. And we have also seen certain important metrics across the Oracle Cloud Infrastructure, which is the compute, storage, and the autonomous database, how it helps an Oracle DBA drill down the Oracle performance issues seen on a database. And we have also discussed how Google Cloud Platform works in terms of monitoring its own cloud resources. And lastly, we have seen the hyperconvergence infrastructure on a Nutanix and a Cisco UCS. So thanks a lot, everyone, for joining. Have a good day ahead.